Okay, so we're going to do some electron configurations and try and talk through how to do these a little bit faster than maybe just counting out electrons, remembering filling orders, all that kind of stuff. So, one of the things you might want to try is when you get your test, immediately go to your periodic table. So I just inserted one in here. We want to fill in some numbers and fill in some information that won't be available given, which will look just like this one if you're taking my class. Now, the first thing is this first two columns, that's the S block. This guy in the middle, that's the D block. And then, debated on how to actually do this, this over here is the P block. Now, just as a little reminder for yourself, maybe write this next to helium, because helium, well, it's written over in the S block, or the P block, because it's like the rest of the noble gases, it only has S orbitals, or really the one S orbital electrons. Now, the other thing that's going to be helpful is just to include some extra numbers over each of the columns. Like this is 1, 2, and then in the D block, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, representing the number of D electrons there. And then for the P block, we got 1, 2, 3, 4, 5, and the last one, 6. So that'll tell you how many electrons. So if it's in this column, all of these have their last electron in a p orbital, and they've got 3 electrons in that p subshell or orbital. Then on the left here, we can go 1, 2, 3, 4, 5, 6, 7. It's really just numbering the row. That'll also be helpful for electron configurations. And then also add these numbers in, because the d orbitals are always one lower. So they're one lower than the row that it's in. So those will be 3, 4, 5, and 6. And if you wanted to, you could include over here 2, 3, 4, 5, 6, 7. The p orbitals follow the same row that they are in. So we threw a lot of numbers in there, but they're going to be helpful when we're trying to figure out these electron configurations. So if I go back up, we want to do beryllium. We're going to do it with and without shortcuts. So for beryllium, we're looking right here. And basically, we can work our way back from or work our way up to beryllium's electron configuration. So because beryllium is in the S block, because it's in row 2, and because it's the second element in that block, we say the last part of the electron configurations for beryllium is going to be 2, S2. I can highlight these so we can get maybe like this yellow. That's how we got that one. Pink, that's how we got the S. And I guess orange is how we get that number there. Now, that's just the last part of beryllium's electron configuration. So if we used a shortcut, it would be helium 2s2. I'm going to go write that in up here. Helium 2s2. Now, the rest of the electron configuration, we kind of just go back and say, okay, well, what does helium actually represent? Now, remember, helium is in the S, and maybe you should even write it's the S2. Helium is always going to be 1s2. So helium is 1s2, so I can replace helium with 1s2, and we can write this as 1s2, 2s2. So that would be both ways to do the electron configuration for beryllium. If we move on to boron, I'm going to reset some of these things on my periodic table, erase some stuff, get rid of those highlights because we're not talking about beryllium anymore, but we're talking about boron. So if we look at where boron is on the periodic table, it's in the second row. So boron's there. It's also in a p block. So it's in the second row. So its last electron configuration part there is going to be 2, p. And then it's the first element in that row. So that's 2p1. So again, try and highlight some of these. 2 is that 2. We get the p because it's in the p block, and then we get the 1 because it's the first one in that block. Now, that's not all of the electrons that boron has. Total number of electrons for boron should be 5, because the atomic number, which represents the number of protons, also represents the number of electrons that boron has when it has 0 charge. So that means that I have all of the electrons, so I've marked basically the last ones. But I also have the electron configuration up to beryllium, and also including helium. So basically everything that comes before this is what is the stuff before that last section on the periodic table. So this will be 2s2, and then if we're using a shortcut, that would be helium. And then if we're not using the shortcut for this one, it would be 1s2, 2s2, 2p1. Actually, I can just copy that and paste it up here. Get rid of these extra highlights. All right, so just using where it is on the periodic table, I'm essentially counting up all of the filled orbitals before I get to whatever element I'm looking for, so for boron. So we move on now to aluminum and reset some of this stuff again. Where's aluminum on the periodic table? Aluminum is here. Right, so what row is it in? It's in the 3rd row. So that's a 3. It's in the P block, so 3p. And then the last part of this, it's the first element in the P block. And then we go and say, okay, well, what is everything that comes before aluminum? It's go over to the left, none of the D block stuff, but here we've got 3 S1, S2. So 3s2 is filled, or the s orbital is filled. 3s2, meaning basically we cover both of those bases. And then if we're using a shortcut, the previous noble gas is neon. So neon. So 3s2, 3p1. Now the electron configuration for neon, if we're going to write out the whole thing, all of this stays the same, 3p1, 3s2. You say neon's going to have, basically it's going to have a filled 1s, it's going to have a filled 2s, and it's going to have a filled 2p. So it's going to be 1s2, 2s2, 2p6. A filled p orbital will always have 6 electrons. So now copy that. It's slightly more complicated doing this on an iPad, right? You could just have the periodic table next to you. I want to be able to show you everything. Okay, so now we'll come back down, erase a bunch of stuff, and we'll do sulfur. So sulfur, again, we want to locate it on the periodic table, is here. So it's still in row 3. So we know this last one's going to be 3p, because it's in the p block. And then it's the 4th element in the p block, so 3p4. Now we can work our way backwards to the previous noble gas. So 3p4, we covered all of these. This would represent a filled 3s2, the 3s2, filled 3s. And then our previous noble gas is going to be neon. Now the electron configuration for neon is going to be exactly the same as it was when we did aluminum, right? We used the same noble gas. It's going to be 1s2, 2s2, 2p6. So it represents 1s2, 2s2, and 2p6. That gets us all the way up to neon. And then it'll be 3s2, 3p4. So that's both ways, shortcut and non-shortcut way to do the electron configuration for sulfur. So we come back down and do calcium. Hopefully you're starting to see some of these patterns and how the periodic tells us exactly where we need to go. So we do calcium now. We're down here. So see, calcium's in a different block. It's in the S block. So when I'm doing the electron configuration, calcium is in the fourth row. So it's going to be, 4s, and it's the second element. Right, it's in that second column, so that's 2, the second column. So that's 4s2. Again, the 4 because it's in the fourth row, the S because it's in the S block, and the 2 because it's in the second column. And now, if we're going to use a shortcut for our first one, we just go backwards to whatever the nearest noble gas is. And since I don't ever leave the S block here, right, there's nothing that comes before that except we go back to argon, then I can just write argon like that. It's maybe a little bit big. I'm going to write it smaller. Argon. All right, so what's the electron configuration for argon, though, if we were going to write this out not using any shortcuts? Well, another way we can think about this is I know I'm going to have to stop at argon, and then I'll add on everything that is the 4s2 to get me up to calcium. So it can be a little bit harder to start maybe at argon, work our way backwards. Just when you're writing things out, things tend to get scrunched. But starting from the beginning of the periodic table, I'm going to go both of those. So that's my 1s2 again. And then this next one, that's 2s2, 2p6. So that got me up to neon. And then we're going to go down to the third row, 3s2, 3p6, and that would get me all the way up to argon. 3s2, 3p6. And since we're doing the configuration not just for argon, but we're going to calcium, right? Now I'm in the fourth row, S block, second one, that's 4s2. So that'd be the shortcut, and then again, non-shortcut way for, I should do it like this, cut it. I don't have to erase it later. Shortcut and the non-shortcut way for calcium. Now for gallium, gallium now is on the other side of the D block in row 4. Now it is not, gallium itself is not in the D block because this is the D block ends here. So it's in the P block. It's in the fourth row, it's in the P block, and it's in the first column of the P block. So that's going to be 4p1. And this is the first time we've seen d orbital electrons. So I have this, since I'm past it, it's completely filled. And that's why we write this 3 in here, because the D block starts at 3. So this will be 3D, and then 10 is the full D block. And then going back beyond that, this is 4s2, 4s2, and then the previous noble gas is going to be argon again. And for argon, I can do 1s2, 2s2, 2p6, 3s2, 3p6, and that would be the same as argon, and then it's 4s2, 3d10, 4p1. That's the full electron configuration for gallium. Set up here, give you a second if you want to pause. All right, now iodine. Iodine, we're making a little bit of a jump here, all the way down to this row. So what row is that? That's row 5. So the last one here for iodine, the last orbital that's got electrons in it, is 5p, again, because we're in the 5th row in the p block. Iodine, though, is the 5th element, so this will be 5p5. And then we work our way backwards. So that means that I've got this full D block here, which I wrote in a handy reminder, that's 4D. And there's 10 electrons, because that's the full 4D10. And then 5s2, And then krypton. This is the previous noble gas. And then this is going to be kind of long. But again, we're just kind of doing the same thing because we're always adding on. So after we fill up one orbital, we just move on to the next one, and then the next one, and the next one, and then the next one, the next one, the next, the next. We just keep going all the way down. So this will be 1s2. Hopefully I don't make any mistakes here. 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Right, we got to remember that 3d10, we're in 4s, go down to 3d first, and then we come back up to 4p6. That whole stretch there is all to just represent what krypton does in a shortcut. 5s2, 4d10, 5p5. There's your electron configuration for iodine, both shortcutted and not shortcutted. Paste those. Not the neatest of handwriting, I know. And then one last one here, barium. Barium brings us all the way down to 6, and I won't give you anything beyond barium in Chem 20 because, well, we don't talk about the F block. So barium is in 6, the 6th row. It's in the S block, and it's the second element in the S block, so that's 6s2. And the shortcut is going to be Xe, xenon. Put that over here. And then we can start 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Don't forget the 3d. It shows up. The periodic table tells you when you need to think about 3d because 4, this would be s2. And then we go 3d, and the last one is 10. And then it would be 4p, and the last one would be 6. 4p6. And that gets me to krypton. But we're going all the way to xenon. 5s2, 4d10, 5p6, and then 6s2, and that's barium. So you can see once you get down the periodic table a bunch, really nice to have those shortcuts. Got that. Paste that in here. So those are all your electron configurations there for those practice problems. Now I did add this at the very end, is go back and circle the valence electrons for each. So that's always going to be the highest principal shell number. So when we're looking at these first numbers, what's the highest number? Well, the highest number is 6. So my valence electrons are represented by, let me circle this in a different color maybe, are represented by the 6s2. In our shortcutted ones, it gets a little bit easier. Now again, looking for on iodine, working our way backwards, looking at all my principal shell numbers, 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5. Well, 5 is the highest out of all of those, so those both represent valence electrons, not the 4d10 though. 5 is 2, 5p5. And so we do that same thing, looking for, whoops, I'm going to circle a 10. Looking for those highest numbers in my electron configuration. So this one, the last one, is just 4. And it's always going to be towards the end of your electron configurations. You can see here for these at sulfur, we no longer have d orbitals that get put in between the s and the p's. So 3s, 3p, that's the highest. 2s, 2p, those are the highest. Here, 2s2. Sorry, I missed some of these. Circle all of them. That would be all of the valence electrons.